All right, so number 9, here we have a 2 by 1 and a 1 by 3. And so we have a match here, and we're going to end up with a 2 by 3. All right, so let's see what happens here. So I'm going to multiply the first row by the first column. That's pretty easy, right? All it is just negative 1 times 2. Okay, and then I'm going to multiply the first row by the second column. So that's just going to be negative 1 times negative 3. And then I'll multiply the first row times the third column. So negative 1 times negative 2. So I'm going to do the same thing in the denominator, right? So I'm going to multiply 3 by 2, 3 by negative 3, and then finally 3 by negative 2. All right, and so that's my resulting matrix. So now I can just simplify. So I get negative 2, positive 3, positive 2, 6, negative 9, negative 6. All right, and just like we thought, it's a 2 by 3. All right, now one thing I want to point out is with normal multiplication, like with scalars, right? Like if I do 2 times 3, that's commutative, right? Commutative, which means 2 times 3 is the same as 3 times 2, right? But with matrices, it's not the same. If I were to multiply this matrix A by matrix B, just like we did, we ended up with a 2 by 3, right? If I were to do B times A, it would be a 1 by 3 multiplied by a 2 by 1. And that can't even happen, right? Because these don't match up. So this would be undefined. Okay, so not only is it not commutative, but sometimes it doesn't even work, right? Sometimes it's not even defined if you switch the order of the matrices. So order does matter in matrix multiplication, unlike scalar multiplication, unlike normal multiplication with just constants, right? Like we're used to with real numbers. All right, anyway, let's take a look at number 10. So here we have a 3 by 1, and then here we have a 2 by 1. Okay, so those have the same number of columns, but the columns of the first don't match with the rows of the second. So this is undefined. So okay, so that's what you write as the answer in that situation. All right, so number 11. So here we have a 3 by 2, 3 by 2, 3 rows, 2 columns, and we have a 2 by 2. So those ones match up. All right, and we're going to end up with a 3 by 2. All right, so let's see how this plays out. So I'm going to multiply this first row by this first column. So it'll end up being negative 4 times 3 plus 4 times 0. Okay, then we'll go first row, second column. So that'll be negative 4 times negative 3 plus 4 times 2. All right, next we're going to do next row times the first column. So it's going to be negative 2 times 3 plus 1 times 0. And then we'll do second row, second column, negative 2 times negative 3 plus 1 times 2. And then we'll do third row, first column, 2 times 3 plus 3 times 0. And then third row, second column, 2 times negative 3 plus 3 times 2. All right, so now we just simplify. So we get negative 12 plus 0. Here we get positive 12 plus 8, so that's 20. Okay, here we get negative 6 plus 0. Here we get positive 6 plus 2. And here we get 6 plus 0. And here we get negative 6 plus 6. All right, so that's our resulting matrix. All right, so let's see. I want you to try out number 12. So first of all, figure out can you multiply them, and if so, what would be the dimensions? Okay, so either write undefined or write the dimensions. After you do that, then go to multiply the matrices together, if possible, and then write submit the answer. Okay. All right. Now, one thing I want to mention is that this can be done in a calculator. So if you want, you can actually go to your matrix menu, second, a to the negative 1 power, right? And you can go to edit, and you can enter in these matrices, right? So you can, this would be a 2 by 3 here. And then you can put that in as matrix A. And then you can put this in as matrix B, and it's a 3 by 1. Okay. And then you can actually, on your calculator, just do, go to second matrix again and just pick A, and then push multiply, use your multiplication symbol, and then go second matrix and get B, enter, or number 2. And then just push enter, and that'll give you the resulting matrix. Okay, that's a good way to check your work. I do want to see the work here, so just to know that you know how to do it by hand, that you understand the process, but you can use your calculator to check your work on these. Okay. All right, let me know if you have any questions. So that's matrix multiplication, and yeah, I'll be happy to answer any questions in class or by email. So let me know if you have any.